right, part 3. And is there another force that we left out?
The force of the rope on the scaffold.
The force of the rope on the scaffold. All right, you're thinking of action-reaction pairs, and I'm not going there. So there is another force.
The weight of the scaffold.
What?
The weight of the scaffold.
Oh, yeah.
And where does that
I
apply?
drew that arrow. I just didn't know what it meant.
I know, Brian, where we apply the weight of, because here
You
we...
could simply add it to the weight of the man.
Yeah, we do, but it has to be from a certain position when we go over to torque. So we decided to do it at the center. So this, I shouldn't have drawn the man in the center because he's really closer to one side. So the weight of the scaffold, I'm going to change that whole blue line and move it to the left.
It's too bad mine's in the middle because I already drew it with color pencil. So.
Let's put the guy closer to the edge because I didn't draw it proportionally. You probably did, correct, on your paper. All right, so we have the force from the weight of the man, but we also have the force of the scaffold itself. And it will be from the center, the very center of the mass. So that weight of the scaffold right there. So this is weight of the man, this is weight of the scaffold. There are 4 forces, they all sum to 0. So I'm going to write an equation over here. The force equation will be tension 1 upwards plus tension 2 upwards minus the weight of the man minus the weight of the scaffolding equals 0. So that's my force equation. Not too bad. Anything that has weight, that's a force, is going to create a force as well as the ropes. Did you catch all 4? That's where you start on these problems. A force equation, it's not too bad. Do we know any of these numbers at all? Put in the ones that we know and look up and see if yours agrees with mine.
Well, you know the weight of the man.
Weight of the man is what, 600? And the weight of the scaffolding we know.
150.
150. Yeah, both negative, downward. So that's about all I can get out of that equation. It's only one equation. It has 2 unknowns. I'll just leave it like that. You could solve it for T1 or T2, but that won't be that helpful just yet. So put that one on hold. And now we skip over to the sum of the torques. And that's where we'll stay the rest of this problem. The sum of the torques equals 0. So every force creates a torque. So how many forces were there? I can see them in blue quite easily. There are 4, so I'm expecting 4 torques as well. Before I start this problem, I have to pick our axis of rotation. So any ideas of it can't be wrong because the thing isn't rotating, but I'm going to give it an axis of rotation. And I will calculate all my torques from the same axis of rotation.
T1.
Put it at T1? All right, let's put it at T1. T2 would work as well. So imagine this was there was a rotation around this point, what would they look like? So we're going to add up all the torques from that point of reference. So this is, you pick it. You pick. Unless it's like a seesaw or something that already has a fulcrum that it's supposed to rotate around. This is not supposed to rotate when you're standing on it. So if you get to pick the axis and make sure it doesn't rotate by adding the torques from that position and making them 0, showing no rotation. You could pick an axis here, here, or here, anywhere there's a force.
You're getting a phone call. Do you want me to ignore it?
From who?
443-421-6320, Maryland, USA.
I'm curious. Hello? Uh-huh. Can I call you right back? Okay, thanks. Bye. Oh, it's
You're so popular, people call
my
me.
daughter-in-law's father. So. All right.
Okay, I'm happy.
It's a 5-minute bell.
All right.
I'm just bored.
How many different sounds
Full
can we get
sounds
out of
today.
this house phone?
Yeah, I know. And now we'll hit the.
How many times is it going to scare me, even though it's sitting right in front of me?
Special meeting things to me. All right, the sum of the torques equals 0 in 5 minutes. We get to finish this problem. We're halfway through, so that's good. Let's look at the torques around this part. Here, I'll start from the axis and do all my torques from nearest to farthest. Doesn't matter what order, but that way I don't lose any. The closest force to this point is this. But when I do that force, well, I'll just write it out. The blue line here is going to create a torque, and it's going to be force times the distance from the axis of rotation. So the force is T1. How far away is this from the axis of rotation?
0.
It's right.
So it all goes to 0.
So it doesn't really help in this equation. I will write it out. The next force is the weight of the man going from left to right. So I'm going to get the weight of the man is 600, and his distance from the axis is 1.2. That's the torque. Torque is not difficult. It's a force times a distance. So then we're going to add another, oh yeah, I have to check the signs, I forgot. It's been a while. This one won't matter, it's zeroed out anyway. But will this be a positive torque? Imagine that this man is the only force on the scaffold, and this is the axis of rotation. Which way will it rotate? Will it rotate this way or this way?
This way.
Yeah, it's going to go clockwise, so we did decide that clockwise was a positive torque, so we're happy there. What about the weight of the scaffolding? Also positive. It would rotate around the axis this way, positively. So the weight of the scaffolding is 150. Its distance, because it's at the midpoint, remember how long was the scaffolding?
5 meters.
5, so halfway is
2.5.
2.5. Now we hit this last torque, and that's T2. We're not sure what its force is, that's what we're looking for. And T2 times what's its distance from the axis, it is 5 away. So let's go ahead then and see what this one should, we only have one unknown, which is helpful here. So solve for T, oh, that equals 0, all that. So if you solve for that, tap away, 600 times 1.2 plus 150 times 2.5. Move that to the other side of the equation. Oh, see, this torque is negative. Why is this torque negative? Because here's the axis, it would cause rotation that way. Because the force was upward, it would cause rotation in the negative direction. So I had to go back and change that to a negative sign. All right. Move the negative 5T2 to the other side and divide by whatever's on the left. And did you get T2 equals 219?
Yeah.
Oh, so it just
And
went up.
we're allowed to
Doesn't it
use.
not? Oh, it has.
Doesn't
All
it
right.
have units?
Where can I go on the board to find T1?
What's the thing that doesn't have units?
Pardon?
What's the thing that doesn't have units that you get that you're solving
What thing didn't have a unit?
for? Do you know?
It was an MS and MK. Remember?
Oh yeah.
All right.
Okay.
What brought that up, Emily?
I don't know.
I was like,
We were
wait,
just
doesn't it not
talking.
have a unit? And then we're like, no.
Because we both thought the same.
Where do I go on the board to
Wait,
find
let's
T1? Where do I go on the board to find T1? Somewhere on the board I can go. Where?
The first one.
Yeah.
Yeah.
Right here. So put in T2 into that force equation and find T1. When you do that, you will get
Calculator. Never mind.
531 newtons.
531.
All right, you have in your possession.
So, Ms. Powell,
Uh-huh.
Okay.
why did you multiply all the forces by?
This is so messy. It really bothers me.
Because this is sum of the torques. Torque is force times the distance.
You have to move it eventually.
You have in your
to the side, so
your possession, a sheet that looks like this. We've already done problems A, B on another page, and C. So your assignment tonight is to do one just like this. So take this home with you, so you have it as a pattern. Your job is to do 2 torque problems.
So
D, we already did A, B, and C. D and E. You need one?
I
You
think
still
I
have it?
I'm gonna write that down. I'm gonna
D
forget.
and E.
bye. Should I turn it off?
There it is.
Yeah,
We're doing
probably.
D and
Bye.
E for homework.
D and E for
Have yours,
homework.
Emily?
Here, I will show you.
D and E. You kind of have
Emily,
it. Okay, we're
I need to borrow
doing
Megan's
D and E
snuggie.
for homework.
tell Megan to need to borrow her snuggie.
And E.
All over his
Okay.
snuggie.
There you go.
Snuggie so
She was
much.
so
Goodbye.
sassy.
He's like,
Bye-bye.